Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Higher Tier Component 2 paper from autumn 2023. This paper is worth 120 marks in total, and this is the first video of 6. It will focus on questions 1 to 4, which account for 17 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 1. Shortbread biscuits are made from flour, butter and sugar. Their masses are in the ratio 4 to 3 to 2 respectively. Part A. What fraction of a shortbread biscuit is made up of sugar? So first of all, I'm going to write that ratio out so I know which section is flour, which section is butter, which section is sugar. So flour, butter, sugar in the order that they're written. 4, 3, 2. So for part A, we want what fraction of the shortbread biscuit is made up of sugar. So our fraction on the denominator on the bottom, that's going to be the total parts in the ratio. So we have 4 plus 3 plus 2. Calculator paper, we don't need to struggle with anything or overload our brain. 4 plus 3 plus 2 is 9. So there are 9 parts in total in this ratio. We are particularly interested in sugar. Now that we've labelled the ratio, we know that that part of the ratio is sugar. So 2 of those 9 parts are sugar. So 2/9 is our fraction of a shortbread biscuit that is made up of sugar. Part B. 1,400 grams of flour is used to make a batch of shortbread biscuits. How many grams of butter is used for this batch of shortbread biscuits? So we're going to move this ratio here down to part B. So flour, butter, sugar in the ratio 4 to 3 to 2. Now they tell us that flour is 1,400 grams. So I'm going to pop that there. So I know that flour is worth 1,400 grams. What I'm interested in is how much butter is used in this particular batch. So I'm interested in that column of my ratio there. So I need to find out what has happened to scale up this ratio of flour from 4 to 1,400. So I'm going to do 1,400 divided by 4, which is 350. So every one part of this ratio is worth 350. So we're multiplying by 350. Now I'm only interested in this part here. So I'm going to do 3 multiplied by 350, which is 1,050. So it's 1,050 grams of butter that are used. Question 2. Lucy bought a car 9 years ago for £12,250. The car depreciated in value by 18% in the first year. In each of the following years, her car depreciated by 15% of its previous year's value. By how much has the car decreased in value in the last 9 years? So this is a repeated percentage change question. You may have heard dealt with some compound interest questions. Depreciation works in the same way. So depreciation means the value is going down. So it's not increasing, it's decreasing. But we've got 2 stages to this. It decreases by 18% in its first year, and then for the rest of the years it decreases by 15%. So I'm going to start with the first year. So for the first year, if it depreciates by 18%, we're starting with 100% of the value and we're taking away 18%. So 100 take away 18 means we're ending up with 82% of the value. Now I've got a calculator, so if I divide that by 100, that tells me that 82% is 0.82 as a decimal. I'm going to use decimal multipliers because it saves me a little bit of time on this calculator paper. So in the first year, the original price was 12,250, but when I multiply it by my decimal multiplier, So multiply by 12 to 50. It tells me that at the end of the first year, the car is worth £10,045. Okay, the next stage is for each of the following years. So 9 years in total, we've done one. So for the next 8 years is what we're working out the depreciation value for. So for the following years, it depreciates by 15% of the previous year's value. So we're starting with 100% of this value. So we have 100%, but we're taking away 15%. 100 take away 15 is 85%. Make that into a decimal multiplier, so divide by 100. So 85% is 0.85 as a decimal multiplier. So we're doing the previous year's value, so 10,045, multiplied by our decimal multiplier, but the difference here is it's happening over a few years now. So we need to pop that power of 8 for those 8 years. So when we put that in our calculator and press equals, we have 2,737.167324. Now we're dealing with money. When we're working with money, we only want 2 decimal places, remember? So I'm going to round that to 2,737.17. So that's how much the car is worth at the end of the 9 years. We need to know how much it's decreased in value by, so we need to know the difference between this and its starting value. So 12,250 subtract £2,737.17. So £9,512.83 is how much it's decreased in value by. So £9,512.83. Question 3. Regan caught 70 fish on a fishing trip. He measured the length of each of the fish in centimetres. The table shows his results. So we've got a grouped frequency table. So we don't know the exact results, but we know that there were 19 fish that measured between 60 and 65 centimetres, 17 between 65 and 70, etc. Part A. Calculate an estimate for the mean length of these fish. So when we're dealing with mean from a frequency table, we need to add in a few columns because we need to work with our midpoint, and then we will multiply our midpoint by our frequencies to get new totals that we work with for the mean. So this is our midpoint column. So the midpoint is halfway between the lowest and highest value within this particular class. So if you can't spot what's the halfway between, do the first and the last added together, so 60 plus 65, and then divide by 2, which tells us 62.5. Be very careful when you're writing in here. Make sure you put your decimals nice and clear so you don't make a mistake later when you're multiplying. Okay, 65 plus 70 for the next one, divided by 2. So that's 67.5. So I can see a pattern here, but I need to be careful and make sure that that pattern follows through. So for sometimes they might have, this has got a difference of 5, but sometimes they might end up having a difference of 10. So just double check that before you spot a pattern. So I know 72.5, 77.5 and 82.5. Okay, so now I multiply my midpoints by my frequency. So 62.5 multiplied by 19 is 1,187.5. 67.5 multiplied by 17, 1,147.5. 72.5 multiplied by 23, 1,667.5. 77.5 multiplied by 10. Some of these, when we're multiplying by 10 or by 1, you might think to yourself, I know what that is. Do it in your calculator anyway, just to be safe, guys, all right? So these are our new totals. So these are the totals that we're working with in the mean. now, so I'm going to add those up. So we have 1,187.5, add 1,147.5, add 1,667.5, add 775, add 82.5. Be careful when you're entering those values into your calculator, guys, because one wrong press of your button is going to get you to a wrong answer. Now, I know none of my working out's down here. It really doesn't matter as long as we're not going into these margins, so don't worry about that. So this is our new total. So this is our total lengths of fish. So to find our mean, we're going to do our new total divided by how many fish in total. Well, handily, they tell us that in the question. So we're doing 4,860 divided by 70. Look, it's still in my calculator. I'm saving myself a bit of time by not clearing it. So that is 69.42857143. Now, it doesn't tell us to round it in any way, so I'm just going to leave it there, guys. Part B. Regan thinks that the median length of fish is in the group 70 is less than or equal to L, which is less than 75. So Regan thinks that the median length of the fish is here in this class. Is Regan correct? Yes or no? We're not going to click yes or no without thinking about this, guys, and we've got to give a reason for our answer. So when we're working with the median from a grouped frequency table, we have 70 fish in total. So 70 divided by 2 is 35. Do that in your calculator if you need to. So the median class from a group frequency table, the median length of fish is going to be the 35th fish, okay? So we're going to do a little bit. I'm going to change the colour of my pen just to make it a bit clearer, if I can find one. We're going to do a little bit of cumulative addition. So we're starting with 19 here. When we add 17, so 19 plus 17, there are 36 fish in total across those two classes. Now, we just worked out that the median length of fish would be the 35th. So 19 are here, and then when we move into the next class, we have 36. So that 35th fish is going to be in this class here, because that's where we ended up counting to 35 and then to 36 for the total. So Regan is wrong. So Regan is not correct, and I'm going to say that's because the median is in the group, and it's this one, remember, because that's where when we were counting up and totaling we got to our 35th. So it's in the group 65 to 70. So we've said no, that Regan's not correct, and told them why, because that's the correct median. Question 4. Jan has a large piece of card. The card has width 60 centimetres and length 96 centimetres. So we have a diagram of the card here. Width 60 centimetres, length 96 centimetres. She uses a machine to cut identical circles out of the card. Each circle has a radius of 6 centimetres. So now we have a diagram of a circle with a radius of 6 centimetres, and then a demonstration here of how those circles get cut out of this piece of card. Diagram's not drawn to scale, so we can't measure anything directly from these diagrams. So here it says, Jan has cut 5 circles as shown on the diagram above. She continues in this way to cut as many circles as possible from the card. Part A, what is the maximum number of circles Jan can cut out of the card? Okay, so let's have a look at this. We're going to use this diagram here because it's really helpful. So they told us here that we've got a radius of 6 centimetres, which means each of these identical circles have a diameter of 12 centimetres because the diameter is double the radius. So what we can do is say that this distance here is 12. This distance here is 12. This total distance of the card is 60. So if we do 60 divided by 12, we'll see how many circles down will be, so 60 divided by 12 is 5. So there'll be 5 circles this way. We're going to do the other way as well. So remembering that this, try not to use the bobbly part of my ruler, this is 12. This is 12. Remember that the diameter is the same at different orientations as long as it goes from the circumference to the circumference, so one edge to the other, but through the centre. So these are all 12. So we can divide this length by 12. So 96 divided by 12. 96 divided by 12 is 8. So we would have 5 circles down, 8 circles across. So the total number of circles would be 5 multiplied by 8, which is 40. Okay. Part B. Jan cuts out the maximum number of circles. So we've taken them out from the card. What area of card is left over? Okay, so we need to first of all find out what the area of card was before we cut anything out. So we're going to find the area of this rectangle. So 96 multiplied by 60 because it's a rectangle. So that's 5,760 centimetres squared in total for the rectangle. Now we know the dimension of the circles. So each identical circle, the area would be pi times radius squared. The radius is 6 centimetres, so the area would be 6 squared times by pi, which I'm just going to write as 36 pi now. If you don't know what 6 squared is, remember just do it in your calculator, guys, okay? So 36 pi. But remember, she's going to cut out 40 of them. So we need to do that 36 pi multiplied by 40 for all 40 circles. So 40 multiplied by 36 pi is 1,440 pi. Again, I'm leaving it in terms of pi because I don't want to write out a load of decimals and I don't want to have to put a load of decimals into my calculator. So if Jan is cutting out 40 circles from this and we need to know what's left, we need to subtract those areas. So we're going to do 5,760 subtract the total area of the circles. So I've left 1,440 pi in my calculator. So 5,760 subtract my answer tells me that it's 1,236.106579. Now it doesn't ask me to round it in any particular way. So I'm just going to write that the area is 1,236 centimetres squared.